Number 7, suppose an equation of the tangent line to f at x equal to 5 is y is equal to 3x minus 8. And you're asked for information here about f and g, where g is defined as f of x divided by x squared plus 10. So the first thing to realize here, y is equal to 3x plus 8. This is the tangent line to f at x is equal to 5. This gives us information about f of 5 and f prime of 5. So f prime of 5 is the slope of the tangent line. What's the slope? We should be able to just look at this and see that this line is slope 3. And the tangent line is slope 3. That tells us f prime of 5 is equal to 3. And now about f of 5, when we plug in 5 into this equation, y is equal to 3 times 5 minus 8. So that's 15 minus 8 is 7. Okay, f of 5 is equal to 7 here. So the tangent line, the equation of a tangent line to f of x equal to 5 gives us both f of 5 and f prime of 5. Okay, so now for g of 5. So g of 5 is going to be f of 5 divided by 5 squared plus 10. F of 5 is 7 divided by 25 plus 10 is 35. So 1 over 5 is our final answer here. And for g prime of 5, well, g prime of x, we're going to use the quotient rule here. So the derivative of f of x over x squared plus 10, it's going to go ahead and write down the denominator squared. It's the low function x squared plus 10 times the derivative of the high function minus the high function times the derivative of x squared plus 10 is 2x. And so now we're being asked for g prime of 5, we just have to plop in everything here. So g prime of 5, everywhere we see an x, we put a 5. Downstairs is 25 plus 10 squared. Upstairs is 25 plus 10 times f prime of 5 minus, that shouldn't have been an f of 5, that should have been an f of x, but now we go ahead and put in f of 5 times 2 times 5. Okay, so what do we end up with? Let's come up here. 35 times f prime of 5 is 3. Minus f of 5 is 7 times 10. All of that divided by 35 squared. And it looks like this simplifies. 35 times 3 is 105 minus 70 over 35 squared. 35 over 35 squared is 1 over 35. But of course, if you just left this as your final answer, that would be completely fine. Okay, in a similar spirit, problem number 8, we're told that f of 2 is equal to negative 7, f prime of 2 is equal to 3. That g of x is cosine x times f of x. Okay, so what is g prime of x? We're going to use the quotient rule. Sorry, not the quotient rule, the product rule. This times the derivative of this. Cosine x times f prime of x. Plus this f of x times the derivative of cosine x. And the derivative of cosine x is negative sine x. Okay, so g prime of 2, and that's what we are being asked for here, is cosine of 2 times f prime of 2 plus f of 2 times negative sine of 2. And then we can just go ahead and use the things that we were given up here. And we can't do anything with a cosine 2 and sine of 2. But we can say f prime of 2 is 3. And f of 2 is negative 7 times negative sine 2, would be 7 times sine 2. Okay, in a similar spirit, h of x is e to the 2f of x plus 3. H prime of x is equal to e to the 2 times f of x plus 3 times the derivative of what's upstairs. The derivative of 2f of x plus 3 is 2f prime of x. Okay, so what is h prime of 2? Same thing, we're going to plop in everywhere we see we're just going to plop in x is equal to 2, and then use these replacements up here. So e to the 2 times f of 2 plus 3 times 2 times f prime of 2 equal to e to the 2 times negative 7 plus 3 times 2 times 3. So this is 6 times e to the negative 14 plus 3, 6e to the negative 11 is our final answer. So it might feel a little bit weird to have this mixture of things that we know about and things that we don't really know about, cosine x and f of x, e to the f of x powers here, but just go ahead, apply, chain rule, product rule, quotient rule, whatever rules that you need, and then substitute in at the end. You'll always be given enough information to figure out what's going on there. Okay, and then last problem in the set, problem number 9 here. Consider the graph of f of x below. For which values of x is f prime of x greater than or equal to 0? And which values x does f prime of x not exist? Okay, so the derivative being positive means that the slope of the tangent line is positive. The derivative being negative means the slope of the tangent line is negative. So, okay, what's going on here? X of 5 definitely has positive derivative. F prime of 5 is definitely positive. F prime of x4, that's a horizontal tangent line. So the derivative there is 0. F prime of x3, the slope of the tangent line there is negative. And so f prime of x3 is negative. At x2, that again looks like the tangent line has positive slope. So for x2, x3, x4, and x5, x2 and x5 have positive derivatives. X4 derivative is 0. X3 the derivative is negative. So that leaves x0 and x1. So first thing here, at x0, realize here that f of x0 is just not defined. And if the function isn't defined at x0, the derivative doesn't exist either. So at x0, f prime of x does not exist. At x1, note that we have a cusp, a sharp corner here. And whenever we have a sharp corner, a cusp like this again does not exist. So that's the information about the derivatives at x0 through x5, and you can use that information to fill in to answer A and B.